what is on your unit circle that
30, 45.
Right, so we're going to say the tangent of 30 plus 45. This is the sum. Your tangent of your first one plus this one follows with the plus on top. On the bottom, it's going to be what?
1
Minus, right? Okay, so that means your x here is 30, your y here is 45. So we're just going to plug those in. The tangent of 30 plus the tangent of 45 all over 1 minus the tangent of 30 times the tangent of 45. 45 is easy. That's the favorite one for tangent, isn't it? It's just 1, okay? 30 is going to be, what, 1/2 over square root of 3 over 2. So it's 1 over the square root of 3. So square root of 3 over 3, right? Did I do that right in my brain? All right, square root of 3 over 3 is your tangent of 30. 1 is your tangent of 45. And then 1 minus square root of 3 over 3 times 1. All right, you're just plugging in. And remember, tangent's just sine over cosine, y over x. So if you have your unit circle, it's y over x. All right, that is your tangent. All right, we do want to simplify this. So with this guy, the biggest problem with him is that your fractions. All right, so we want to get common denominator in the numerator, common denominator in the denominator. So we want to do all of this. So let's look at this guy. My common denominator is going to be 3, right? Square root of 3 over 3 plus, what is 1?
30.
It's 3 over 3, right? It's always, if it's 1, that's easy. All right, so that's him. All right, this guy is also 3. So we have 3 over 3 minus the square root of 3 over 3. All right. When I'm adding fractions, I just add my numerators. So don't overthink it. All right, I just on top have square root of 3 plus 3, and that's all over 3. That's my numerator, right? Just add your numerators. On the bottom, I have 3 minus the square root of 3 over 3. Remember I said when you have fraction over fraction, what happens? And it has the same denominator. My denominators actually cancel here. If I keep change flip, which you're welcome to do out if you want to, but when your denominators are the same, they end up canceling. And I end up with numerator over numerator. And I think your answer key actually simplified it more.
So that's your answer?
No. Why is that not my answer? Okay. We need to rationalize it. How do I rationalize it? Conjugate, right? Y'all remember conjugate, that little term there? All right, on the top, we're going to FOIL. Square root of 3 times 3, that's just 3 square root of 3. Square root of 3 times square root of 3, that's just 3. 3 times 3. Then 3 times the square root of 3. On the bottom, it's the square of the first guy. That's just 9. Minus the square of the second guy, which is just 3. The hardest part here is just the algebra of it, right? Dealing with all these fractions. All right. Then I'm going to simplify on the top. I have 3 square root of 3 plus 3 square root of 3 gives me 6 square root of 3. 3 plus 9 gives me 12. And on the bottom, I have 6. What can I take out of every single number there except what's inside my radical? A 6. So I can divide everything by 6. That becomes 1. That becomes 1. That becomes 2. So I have the square root of 3 plus 2. That is my answer. On the first one, we took one that we didn't have and we spread it out. On these, it is given you it spread out and you want to condense it. So you're going to see cosine, cosine, sine, sine. Which of your 3 sum and difference identities does that look like? The cosine of the 2 subtracted, right? So this is going to be the same thing as if I take these 2 and subtract them. Okay? Everybody see that? All right. Yeah, well, I mean, those are my only 2. They're actually the same thing. All right. So 25 pi over 18, 23 pi over 36. I am subtracting fractions. What must I have? What is my common denominator? It's 36. So multiply the top and bottom of this guy by 2. So that's the cosine of 50 pi over 36 minus 23 pi over 36. What is 50 minus 23? 27 pi over 36. What goes into both 27 and 36? Right, so I'm going to divide these by 9 to reduce my fraction. 27 divided by 9 is 36 divided by 9 is, all right. Cosine of 3 pi over 4. 3 pi over 4 is a pi over 4, first of all. There we go, pretty one. We know it's a square root of 2 over 2. What quadrant is this going to be in? Second, and cosine is negative in my second quadrant, correct? So what is my answer here? It's just wanting you to recognize the formula. So which one does sine, cosine, cosine, sine? Your sine. And sine follows it, right? Since it's plus, it's going to be plus. So this will condense to just the sine of these two angles added together, 4u plus negative 3u, right? I can condense it that way. What is 4u plus negative 3u? Just u. Well, that's your answer.
So that by solving, you mean like...
So I will not give you where you have to go around the circle more than once, right? This is the same thing as 3 pi over 2 to 2 pi. All that's doing is telling you what quadrant you're in. That's the only thing it's doing, is telling you what quadrant you're in, okay? And so what quadrant are you in here?
Hold on. 3 pi over something.
The fourth quadrant.
Right here. Here we are. We're in fourth quadrant, okay? So that's all it's doing, is trying to tell you what quadrant you're in. Cosine is 3/5 in the fourth quadrant. Find cosine of 2 theta. There are 3 different cosines you can use. They gave you the cosine. Which one are you going to use? Which of those 3 double angle?
Cosine 2 equals 2 cosine squared minus 4.
Yeah, so if I were doing this and they gave me cosine, I'm going to do this guy, right? Did I write that correct? So once I know which one I'm using, I'm really just going to plug this guy in. So I'm saying 3/5 squared minus 1. 3/5 squared is...
Is it 2? It's 2 cosine squared. 2 cosine squared minus 1.
Sorry. 2, 2, 2. Thanks. All right, so we get 18 over 25 minus, and this is 25 over 25, right? So what am I going to get?
7.
Negative 7 over 25. I want to solve this equation. My problem is that I have a cosine of 2 theta and a cosine of theta. So I need to simplify this using one of my double angles. Which one of my double angles do you think I would use here?
2 cosine squared minus 1.
Yeah, I'm going to use actually the same one I just used. And I'm going to replace that with 2 cosine squared of theta minus 1. Okay. And so I get 2 plus 2 cosine squared of theta minus 1 equals negative 3 cosine of theta. I really want to solve this by factoring, so I'm going to move that 3 cosine theta over, okay? So I'm going to take this and I'm going to move it over to the other side. And I'm going to rearrange this. I'm going to put this first, 2 cosine squared of theta, and then I'm going to combine my 2 and my 1. So that's just going to be 1. So move this 3 over. So plus 3 cosine of theta, combine my 2 and my negative 1 equals 0. Now, the easiest way to factor this is to think of those as x squared. So I'm going to do this little sidebar over here. Okay? I have 2x squared plus 3x plus 1. That's what I need to factor. Okay? Does that make sense?
Yes.
There's only 2 factors of 2 and there's only 2 factors of 1. It's really easy factoring. Yeah, so I'm gonna have to say 2x plus 1 and x plus 1. I mean, that's my only options, right? 2 and 1, 1 and 1. That's all I got, okay? See if it works. 2x times 2x times x is 2x squared. 2x times 1 is 2x, 1x, that's 3x. 1 times 1 is 1. Does everybody agree that's my factoring, okay? So when you see the cosine squared and the cosine, think of it as a variable squared and a variable. All right, so I'm going to rewrite this, and I'm just going to put my cosines back in here. So it's going to be 2 cosine of theta plus 1 cosine of theta plus 1. Yeah, because that's how I'm solving by factoring. So I'm going to solve each one of those equal to 0. So I'm going to say 2 cosine of theta plus 1 equals 0. Cosine of theta plus 1 equals 0. What do I do here? Subtract 1 and divide by 2. So cosine of theta equals negative 1/2. All right, over here I just subtract my 1. So cosine of theta also equals negative 1. So I'm going to look on my unit circle, and every time my x is negative 1/2 or negative 1, I will get my answers.
So 2 pi over 3 and 4 pi over 3?
Right, so let's look at, yeah, so 1/2, cosine 1/2 is going to be a 60-degree angle, so pi over 3. All right, and it's going to be negative. So it's going to be second and third quadrants. All right, so this one's going to give me 2 pi over 3 and 4 pi over 3. There's only one place where cosine is negative 1. Where does that happen?
Pi.
At pi.
Okay, that's my theory.